Here are some examples from 5.1. Example number 1. For each of the following, write an equation for the function, then sketch a graph on the interval of x belongs to negative 2 pi all the way to positive 2 pi. The first one that they want us to graph is a sine function with an amplitude of 2 and is reflected in the x-axis. So what I'm going to do is take all of that information and put it together into an equation, and it might look something like this. So we have the sine function, and that's why we put y equals sine x as our base function. When it says an amplitude of 2, it means that our a value is going to be 2. Then reflected in the x-axis indicates that we have a negative as our a value, and then also that it is a vertical reflection. Okay, now that's our equation. All we have to do now is graph it. So the method that I like is the mapping notation, which means that I'm going to take the 5 major points on a sine graph, I'm going to apply the transformations, get my new coordinates, and then plot them on a graph. So here are the 5 major coordinates of a sine graph. Remember, sine starts at 0, 0. Also notice that all of my x values are not in degrees. We're going to use our radian measures instead. Okay, so since we have these two transformations, why don't we start to apply them? This is a vertical stretch by a factor of 2, and then also a vertical reflection over the x-axis. Those two transformations are vertical transformations, which means they should apply to the y values and not the x values. Okay, now when you take your vertical transformations and apply them to your y values, nothing changes. So the negative 2 will be seen as exactly the same as it was before. You're going to take negative 2 and multiply all of your y values, giving you brand new y values. Notice that the x values have not changed. Then what you're going to do is you're just going to graph. Okay, so all the blue coordinates are our new coordinates. Hey, that kind of rhymed. And we just put them onto the graph. Your graph should have an x and y axis labeled. You need your equation. And here's a little bit of a tip. Whatever the denominator is, we're going to actually put them as our ticks. So for instance, my scale is going to go up by pi over 2's. And that just helps me to graph a little bit easier. So let's check it out. 0, 0 is right here. Pi over 2 and then minus 2 is right here and right there. So I'm going to draw a dot right there. And then we have pi 0, 3 pi over 2 and positive 2, and then 2 pi and 0. So that makes our graph, and I'm just going to stretch it to negative 2 pi all the way to positive 2 pi. Now let's just make sure that that's exactly what we were asked for. This is a sine graph. It does seem like it has an amplitude of 2 because notice that it goes from max of 2 all the way to a min of negative 2. Lastly, sine usually goes up, down, and then up again, but this one went opposite, down, up, and then down again. So that means that there should be some sort of a vertical reflection, and that means that we have the right answer. Let's try another one. So this is B, and we're asked to create an equation and also graph a cosine graph with a phase shift of 2 pi over 3. Okay, so a cosine function means that we want a base function of cos, and a phase shift means that it's going to be a left or a right. Now, if they have a positive 2 pi over 3, we actually enter it into the brackets beside the x as the opposite of what they've actually mentioned. So that was always kind of strange. Anything that's inside here, transformation-wise, is going to be the opposite of what we think. So again, if this is a positive, this is going to be a negative. Now, let's do that mapping notation again. Here are the 5 major points on a cosine graph, and we're going to apply this transformation, which is to the right, not to the left, which is what I guess most people would normally think a left is negative, but no, this is the opposite. In fact, it goes in as opposite as well. So notice that this is a horizontal transformation because it goes left and right. Okay, well, this one specifically goes to the right. And when we put it into the mapping notation, it's going to go with our horizontal values, which are our x values, and notice that you're adding 2 pi over 3 instead of subtracting. So again, that opposite factor is being applied. Okay, so nothing's going to happen to our y values and we get all these new values. Okay, so you're just using common denominator in order to add these guys, maybe a common denominator of 6, which will then change your numerators. So just be careful when putting them together. This is going to be our new coordinate system. We're going to use that in order to graph now. Okay, so I'm just going to go down a little bit. Whichever denominator has the highest number, that's usually what I like to break up 0 to pi into. So since 6 is larger than 3, I'm just going to break it up into 6 pieces. See, 1, 2, 3, 4, 5, and 6. What you might want to do is you might want to write this as an equivalent fraction with a 6 on the bottom instead. So for instance, if I wanted a 6 on the bottom, I would just double this and double this. So it'd be 16 pi over 6. And that just allows you to count a lot easier. Okay, so for example, this coordinate right here, 16 pi over 3, I think it goes a little bit too far. So you know what? How about I do this one? This would be 10 pi over 6. So 10 pi over 6, 1 pi over 6, 2 pi over 6, 3, 4, 5, 6, 7, 8, 9, and 10 pi over 6, and then negative 1. So there's my coordinate right there. Again, make sure that you label your axes, and you always want to write the equation very close to your graph. Okay, so the next one we're going to look at is going to be a sine function with a period of 3 pi. Okay, so this one's a little bit different. We want to make sure that we calculate something that has to do with the period, so that would be our k value. This is a formula that we've seen. In grade 11, we had a 360 degrees at the top, but now in advanced functions, we just change it to a 2 pi instead. They've told us that our period is 3 pi, so I'm going to put that into where the period is supposed to be right here and cross multiply. So 3 pi k is up here, is equal to 1 times 2 pi, which is 2 pi. Then I want k by itself, so I'm just going to divide out a 3 pi over here and here, and then also on the other side. These pi's are going to cancel out, and I'm just going to get a k value of 2/3. So the k value goes in front of the x, and this is going to be a horizontal, I think it's a stretch by a factor of 3 over 2. So do you see what I mean? Like anything inside this bracket is the opposite of what we would think. This is 0.67, which we would assume is going to be a compression, but it's a horizontal stretch. And then we think it's by a factor of 2/3, but it's not. It's a factor of the opposite, upside down, 3 over 2. Okay, so they've given us a sine function, so we have sine, and we're just going to go through all of the answers. Oh, I think I have that in my next slide right here. So this is just the mapping notation. Notice that I've multiplied by the opposite, 3 over 2, instead of the original 2 over 3. And we've done that to all our horizontal values, which are our x values. So I got my new horizontal values, all the y values didn't change, and we're just going to graph, and it looks something like this. All right, now the very last example we're going to go through is a little bit tricky. Example number 2 says a pendulum swings back and forth 10 times in 8 seconds. It swings through a horizontal distance of 40 centimeters. So A, sketch a graph of this motion for 2 cycles, beginning with the pendulum at the end of its swing, and then write an equation that models its situation. So I'm going to show you the entire solution. I know it's kind of colorful, but hopefully you can follow me. This 10 times in 8 seconds tells us about the period. So if you have 10 swings in 8 seconds, that means every time it takes about 0.8 seconds in order to complete the cycle. So that is the period. Okay, now the horizontal distance is going to be along our graph. Let me just scroll down a little bit so you see it right up here. And then this little piece of information means that that's how much your pendulum is swinging completely from max to min. All right, so what we want to do is we want to graph starting at the beginning of the pendulum. So let me explain what this looks like. Okay, so we already know that the cycle has to last for 0.8 seconds. Or was that minutes? I think that was minutes. Nope, seconds. Okay. All right, so basically what's happening is imagine that someone is standing here and what they're doing is they're swinging a pendulum back and forth. So it's going to go back and forth, and you know what? You have to be, let's say the person is standing and they're looking towards this way. So technically this is their horizontal distance. I know it's kind of weird, but the question's just worded really strangely. So horizontally, it's swinging between 20 to -20, which is an entire 40 centimeters horizontal distance. Okay, so the 20, which is our amplitude, is going to go right here as our A value. Okay, then our period is going to be 0.8. So we're going to use our formula to cross multiply. 0.8k is equal to 1 times 2 pi. Divide out the 0.8s and you actually get the k value. So that's going to go into our equation right before our independent variable. So that is our t. Okay, now I knew it was a cos because it started up here. They had mentioned in A that it starts at the beginning, the beginning of the pendulum is at the end of its swing. So in other words, it's not starting from the middle, it's starting all the way at one end and then going towards the other. So this is one of the possible equations that you could have, but you could have also started at this end of the pendulum and then swung it this way instead, which means that you would have a negative 20 cos 5 pi over 2 t graph. Okay, so you can have several different equations for this, but this is just the one that I decided to use. And again, it's a cos because it kind of maps out the cos's shape. Okay, so these are a couple of different examples that you might see in 5.1. There are obviously a bunch of them, but they do align with a lot of the ones that we've seen in grade 11. The only difference is we're just using pi's instead of degrees.